Hello, everyone. Thank you for coming. Great presentation by Guy right before this. So hopefully I'm going to piggyback on that and kind of go through a little bit about like building applications on the Lightning Network. I'll talk a little bit kind of about more general things. I'm not going to try and repeat a lot of Guy's stuff about like what is the Lightning Network. I'll kind of breeze through that. But this is a workshop, so I definitely want to keep it pretty collaborative. So if you have a question, just raise your hand, and like we can kind of go. We'll make this interactive. So definitely, interrupt me, whatever, and I'm happy to answer questions as we move along. So briefly about myself. So my name is Krizek. I'm founder and CEO of Voltage. Voltage is a Bitcoin infrastructure provider, so we help companies leverage Bitcoin, the Lightning Network, all of these tools and services, and understand kind of how to bring this technology into your business, your products and services of what you're doing. I've been an engineer for a long time, been a Bitcoiner for a long time, and so that's kind of what led me to create Voltage. Is it's the kind of this natural mix of we need infrastructure, we need easy tools to start working with this stuff, and there's obviously that gap in the market. So for Voltage, we launched in October of 2020, infrastructure provider for Bitcoin, like I said, and we're very Lightning Network focused. So we do general Bitcoin things, but definitely. Our most prominent product is like our Lightning node hosting and liquidity and all of these things. So we're definitely, I guess, most known for what we do with the Lightning Network. So I have QR codes throughout this presentation. I didn't realize how small this screen was going to be, so they're probably pretty useless, but you can go to the website if you want to. So what is the Lightning Network? So the Lightning Network is a layer 2 scaling solution for Bitcoin. So it was created to try and solve the issue of, Bitcoin needs the block, confirmation times, which can lead to, slow transactions if you need, depending on how much assurance you need of the transaction. Being able to do more, the instant payments, global payments, it enables a lot of us to use it in a more normal payments mechanism rather than like the base layer, which has its own unique properties that lead that are for its security. And so Lightning Network enables instant, cheap, and truly peer-to-peer payments. So what can Lightning do? Payments, duh. Like that's an obvious one. But when you really think about payments is easy, like we understand that. But when you think about it in a more deeper sense, the Lightning Network can do like cryptographically secure payments. So you can have the assurance that that when you get a payment from this person or like someone pays an invoice that it is it's real, it's valid. There is the cryptography behind it that actually you can prove that this invoice was paid. It's very privacy focused as well. I don't want to say it's completely private because there are some privacy issues to still solve inside of the Lightning Network, but it is very privacy focused as a network. And then it's also it can enable microtransactions, so you can send one Satoshi payments very, very easily, where you think about doing that in any other context, sending less than a cent just isn't really possible or doesn't make sense. And then autonomous payments. So with this, you can essentially send payments just like TCP packets on the internet, or do web calls or something like that. So when you think about the possibilities of actually doing peer-to-peer payments in an automated way, there's nothing that is better than the Lightning Network, because it has this, you can do completely autonomous, just completely script an entire payment workflow very, very easily. And then additionally, it's fast payments. So I have an asterisk by fast because I'm sure there's people who are like, oh well, Tor's slow or something. It's like, yeah, sure, whatever. But you think about when you think about doing a credit card payment or something, behind the scenes the bank has to have a certain amount of days to actually validate all of those things. So it is fast payments inside of the true finality of it. And so so with all of those things that it can do, we're able to embed payments in everything, which is really not possible previously, especially when you think about what you can do with paywalls. You think about, you go to the New York Times website and it says, hey, get our $8 a month subscription to read this page. I don't want to do that. I want to read this one page, and I'll pay 10 cents to read this one page. Well, entering in your credit card details for a 10-cent transaction sounds pretty awful. And so you're able to really embed payments into more things. I think that the flip side of that, though, is you can get really you want to be careful about the user experience of, if I want to charge nickel and dime everyone for every little single thing you do. And so there's a lot that you can do inside of what people are working on with WebLN to kind of embed Lightning payments more natively into the web with browser extensions and things like that I think can do a lot in terms of metered pricing and things like that, and actually paying for literally only what you use. But being able to, I think, embed payments and a lot more things is really it opens up so many doors in a lot of different industries, really across the board. And so what are kind of like a lot of the market opportunities I see inside of like people that are building on the Lightning Network? Obviously payments, everything that I just mentioned, but then there's all these other things inside of the Lightning Network that are like opportunities that need to be solved. So we have like liquidity, we have metrics, we have security and compliance. So like all of these things of, okay, sending payments is like, honestly, that's the easy part of like actually using the Lightning Network. Like sending payments is pretty easy. Well, the hard part is, okay, thinking about liquidity. How does liquidity actually work? How do I manage my liquidity in an efficient way? How do I get those metrics from both my own node as far in the graph? And how do I do this all secure in a very security-centric way? And those are the really hard parts. And so that's like, the market opportunities that still are, Voltage is solving, other people are solving, and there's still a lot to go inside of these. But really, when you think about all of these different aspects, this is just an entirely new way to monetize whatever you're doing. We're talking with people that are in the energy sector, or, the payments, or gaming, whatever. All of the industries across the world can really benefit from Lightning in one way, shape, or form, whether it's you literally pay for every kilowatt hour that you're using like instantly with Lightning, or if it's just like even just settling your bill like once a month over Lightning or something. There's a lot of ways that you can leverage the technology, and it really opens up the door to do more things. And I think that it benefits the company as far as being able to open up new ways to monetize, as well as a better user experience for the user, like that example I gave of like the newspaper and like paywalls and things like that. So like what we see people like kind of building right now is like a lot of e-commerce stuff. That's kind of the natural, like, okay, Lightning is a payments network, so a lot of people do payments with it, of like in like buying a ticket for something. So we see a lot of that, but then we also see a lot of things like streaming, like the value for value, podcasting 2.0 movement, and then a lot of like experimentation of people that are building like the Sphinx chats of like this decentralized chat on top of the Lightning Network. And so there's a lot of different things being built, and I think that above all else, there's a lot of like experimentation going on, which is great, like figuring out what works and what doesn't work, and how are we actually going to use this technology, in a real way going forward. So a bit of a lingo breakdown. So we have like nodes inside the Lightning Network. That's essentially your server that is responsible for communicating with your peers on the network. And so the nodes establish channels to other nodes, and those are what Guy was talking about with being able to transact in the Lightning Network. You have to have a channel established, and you use your node to establish the channels. Your node has to be online to send or receive, and then your node is essentially like your identity, like that pub key, like when Guy was showing that big graph of like all the things, those are the nodes. Liquidity is essentially like the funds that you have on the Lightning Network. That's how much you are able to send or receive. You have to have liquidity to be able to transact, and then you're limited in how much you can transact by how much liquidity you have in either direction. I'm kind of glossing over a lot of these terms because I want to get more into like actually have a demo and building things. So when you start up a brand new node, this is what your liquidity is: 0. You have nothing on either side. You have no liquidity. And so shout out to Paul up here for these screenshots of the node things. I stole them from him. But so then you open up your first channel. So I opened up a 100,000 sat channel to async or someone. So now I have the ability to send up to 100,000 sats. And then once you actually transact, okay, that's moving that from your side of the channel to their side of the channel. And so now you're able to you could receive a payment up to 20,000 sats, or you could still send a payment of 80,000 sats. So that's how liquidity kind of works inside of the network. It's everyone uses kind of like the abacus beads like as an example, which is actually a pretty accurate way to think about it. And then additionally, if I'm going to say I'm going to buy a 100,000 sat channel, so someone else opens up a 100,000 sat channel to me, I'm not able to send out of that channel at all because I have 0 on my side, but I can receive up to 100,000 sats of inbound for it. And then going into credentials. So when you have your node, your credentials are how do you communicate with a node? And each implementation has a little bit of a different way of doing the credentials. LND uses macaroons. C Lightning uses something called runes. And these are essentially like an API key. They have a little bit more functionality than just a normal API key you get from like a web API. But you can do very very specific permissions with these credentials of like limiting it to an IP address or other kind of custom validation that you want to do to ensure that this credential can do exactly what you want it to do and not anymore. Then obviously these are meant to be kept safe and private. They are your credential into the node to actually send and receive, do all of these things. And then finally APIs. So this is how you communicate with the node. This is how you do those sends, receives, all of those things. And this is essentially what all of the tools and dashboards use. When you think about Thunderhub or Ride the Lightning or any of these tools that are kind of interfaces on top of your node, they all use the APIs, and that's how they get their data, visualize it, and perform actions. There's several different APIs inside of these node implementations. Usually they're either gRPC or REST. REST is the pretty normal, I would say, way that most APIs function. gRPC is a little bit of a newer kind of remote. What does RPC stand for? Now I'm forgetting. Remote procedure call. Thank you, Paul. And so there's it's essentially the API is really your entry point into the node and being able to do all of these things that you want to do. So I made a really quick diagram to try and communicate this, and that because this is something that we get a lot of like, if your node is running on Tor, okay, but does my API communication have to go over Tor or what? But like really, your node has two methods of communication. One is to the peer-to-peer network. That's when you're communicating with your peers, opening up the channels, staying in sync with all the other nodes on the graph. That's the peer-to-peer communication. That is fairly common to run over Tor. And then you have the API communication, which is you interacting with that node to send and receive, or like issue those commands to the node. This is, I would say, less common to run over Tor. Some of like the at-home like node boxes like Start9 and Umbrel and all of those, like I think they expose like the APIs over Tor, but it's more common for that to just be ClearNet, I guess. And so like, how do you actually integrate Lightning? Like if I have this idea, I have this app or whatever, how do I integrate Lightning? So there's a lot of, there's several steps to it. And one, you have to have like highly available architecture. So like I was saying, you need to be online. If you want to do anything serious, besides just kind of like a personal wallet, you need to be online all of the time. And that's important for your node to have good, ranking as far as like the network is concerned, but then also your ability to route or send and receive. If your node's down, you can't do any of that. So it is very important that your node is online all of the time. And then also you need to have a good strategy around the API communication as far as like those credentials go, your like access to the APIs. So us on our Voltage platform, we have like an IP whitelist, so you can tell our platform what IP addresses are allowed to talk to your node, so you don't just open up to the whole world. And then having a method of doing those notifications for payments or invoices, which is something I'll kind of get into in a demo. And then things like adequate observability. This is one of the real challenges in the Lightning Network is, once you have a node up and running, you're doing transactions. Okay, how do I actually like get the data out of like my transactions of like who paid what? Being able to see how is my node performing over time. This is something that we're working on a solution for as well called Surge. And so there's, above all else, there's no single example of like, here's the textbook on how you integrate Lightning, because it's very specific to what you're doing and what you're building. So those are just some bullet points. So so with that, I'm gonna go through a little bit of a coding thing. Again, QR code. But if anyone wanted to follow along, I have this repo at github.com/voltagecloud/BBBBB. That's 5 B's. You'll see why in a second. So if anyone wants to follow along, like go for it. I'll leave it up here for a second. I see some QR scanners. Okay, so while people are scanning the QR code, this is a bulletin board project. This is like an example, like bulletin board. So it stands for BitBlockBoom Bulletin Board, is what the B's stand for. So with that, so a few definitions to go over before we get into the project. And one, key send. So key send is a thing inside of the Lightning Network that essentially allows you to send a payment without requiring an invoice. So when you're doing payments on the Lightning Network, the way it was like initially created was that person A generates an invoice, sends it to person B, and person B pays that invoice. Great, but what if I want to gift my brother $50 for his birthday? I'm not going to go ask him, hey, can you generate an invoice for me, and then I'll pay it. And it's like that's just a bad UX. So we want to be able to do a more Venmo-like payment of just, I just want to send them $50, and that's it. And so that's what KeySend does, is it's the ability to essentially just send a payment to a peer on the Lightning Network. It still uses invoices and things like that. Well, not invoices, but like the whole pre-image and all of those things behind the scenes, but really that's abstracted from you, so you can just send a payment to a peer. TLV. So TLV stands for type length value. That's something that you can put inside of a Lightning Network payment that's essentially metadata. It's essentially having you can add additional context to the payment that you're doing. This is what people like Sphinx Chat and Podcast Index and some of those use, is TLVs. So when you're in Sphinx Chat, when you're sending a message to someone else, it's using TLV. It's putting that message inside of the metadata of the payment, and so it's just a way to add extra data inside of your payment. And then finally, gRPC. Kind of touched on it earlier, of remote procedure call. So this is the API that you're communicating with into the node, and we're going to be using gRPC in this example. So that's good. So let me share a bit of code here. I'm going to have to make this bigger. Holy cow, that's tiny. Okay, so starting with this. So this is our, sorry, let me get my windows adjusted here. This is our example project. So what this is right now we have a bulletin board project, and what this does is we have a REST API exposed where anyone can post to the bulletin board by just hitting our API. So I'm gonna run just the bare bones example of of just our bulletin board project. So you can see, okay, so server starting on port 8080. So if we went to a web browser. Sorry, this is like ridiculously small, and I was not prepared for it to be this small. Okay, so this is like our bulletin board. So these are messages that people have put that I did just a few minutes ago. And so we can see, let's send a new request to this API of like new message. Okay, we did that. We got the new message. We see it up here on the bulletin board. So great, that's all cool. That's like a normal web app. The problem is we get a bunch of spam, right? It's an open API. People are just sending messages at will, and it's bad user experience. Everything is bad because people are just sending bad messages. So what we want to do to enhance this experience is add payments to it. So whenever you want to post a message to this bulletin board, you're gonna have to pay to do it. It incentivizes people, it kind of disincentivizes the spam because it's not free. You have to actually pay to put a message on this bulletin board. So how are we going to do that? We're going to use KeySend, like I mentioned, and TLV. So we're going to be able to send a payment to this bulletin board node and add a message to the payment, and then we will watch for invoices. We see an invoice come in that's paid, and then we find the message inside of that invoice, and then we post it to the bulletin board. So we're fighting spam in this bulletin board project is what we're doing by adding Lightning. So how we would do that is like normally, so I'll do a quick this is voltage. So step one is you need a node, right? You need a node to be able to actually go and use, integrate Lightning or anything like that. So on voltage, we could create a new node. We'll go with LND. We are using testnet right now. I'm just demoing real quick how easy it is to actually create a node. So we could I'll name this BBB whatever 2 because I already have a node called that. And so write down your password, remember your password. Don't actually skip over that in real life. And then so then this is just going to provision it, behind the scenes. I already have some nodes set up to be using for this, so we can because these are on testnet, so I already have channels established and everything, so we don't have to actually wait for confirmations. So this is our node that we're going to be watching invoices for. And so going back to the code, so we have the example project here. Let's go to the results piece. Because of time, I'm not going to actually live code this. I'm going to be more copy and pasting and explaining copy and pasting. But so first, is, so the first thing that we want to do inside of, we got rid of like the post request of this server where you can see the method of posting. So we got rid of that because we do not want to actually enable people to add messages to the bulletin board without paying an invoice. And so what we want to do is add support for Lightning. So the first thing is we want to set up communication to our node. So that's what this function does, is gRPC setup. So we have this API endpoint for our node. LND by default listens on port 10,009. And being able to, inside of Voltage, like the things that you need to connect to a node are your endpoint, normally a TLS certificate, and then the macaron, that API key. With Voltage, you don't necessarily have to pass in a TLS certificate because we have like CA signed ones, but for the sake of the demo, we can pass in a TLS certificate, and then we specify the macaron, and then with that, we can set up the gRPC library. So by doing that, so we've set up all of the communication all of the details required to communicate to the node. So we can see, if I go into the results one, if I do go run, we can see that I have logged here the node's pub key. So that means that we're able to call to the node and actually receive its pub key, and so that's kind of like proving that, okay, hey, we have communication to the node, we know that we're listening on this address, and so this gRPC setup is functional. Next is the thing that we set up a new LNRPC client. So this is I'm using Go, obviously, if no one picked up on that yet, but LND has an LNRPC library, so it's an easy way to communicate with a node. There's SDKs in almost every language, at least the popular ones, like Node.js, Python, whatever. And so with the library, we're able to create easy methods of communication. And so we set up a client, and then this is that get info call that I just called to get the information for the node, and we're able to see the pub key attached to it. Okay, so that's all good. So our project now is not listening. You are not able to add messages to the bulletin board via the API anymore. And now we're able to connect up our project into the communication to the Lightning node. So we have that set up. But now we need to actually listen for invoices and watch for payments to come in, and then know when a payment is made and check that message. And so with that, there's this subscribe invoices call, which is a streaming call from LND. And so with that, we're able to hook up a stream from the Lightning node and just constantly listen. And anytime an invoice comes in that's paid, it comes to our stream, and we're able to process that and figure out what we need to do with it. So we set up the subscribe invoices stream, and then we just listen for payments to come in. And so when a payment comes in, we can see we receive the invoice, and then we first look if the invoice is settled. So if we need to look if the invoice is settled, because if we just get a payment that's not settled or failed or something like that, they don't get a go on the bulletin board. So we first need to check that the invoice is settled, and if it is settled, then we say, okay, great, we got an invoice that's settled, and then we need to look inside of the HTLCs. So HTLCs are the hash time lock contract that are inside of Lightning payments. So you could have, the reason why you have to actually look into the HTLCs is that a Lightning invoice could have multiple HTLCs with like multipath payments and things like that. And so we have to actually look at the list of HTLCs inside of this payment, and we're going to loop over to HTLCs, and then we're going to look for the custom records, which is the TLV, for this specific number. So how TLVs work is that you can't, it's not necessarily arbitrary JSON. You have to actually like add like a number as the key. And so when you think about like Sphinx Chat uses, I can't remember what their number is, but there's specific numbers for specific applications. KeySend has its own, it uses TLVs and it has its own specific number. For the sake of my demo, I'm using 420. So whenever someone wants to post to the bulletin board, they have to add the TLV of their message has to be on key 420, 420. Otherwise, that's kind of my apps is just kind of, we just got to communicate that to our customers that, hey, our TLV value is 420, 420. And so anyone that sends a payment that's not, has a message not on that, we don't see it. And so it's kind of like the requirement of like the API, so to speak. So we look for any custom message that is on that value of 420, 420. If it's not blank, if there is a message there, that means that we found the message, and then we're going to write it to the bulletin board. So with that, we should be able to listen for invoices. We see an invoice. We check if it has the right TLV value on it, and if it does, great. We're going to post it to the board. So watching that in real time, so I have it right here listening for it. So you can see my previous attempts. But so what we're going to do is we're going to use LNCLI to communicate with the node. LNCLI is the CLI into LND. It's probably obvious. But so we first need to specify the RPC server. Can you guys read that, or is that too small?
It's too small.
Yell at me. Say it's too small. Is that better? So we got to first specify our API endpoint for our node. And then we have to give it a TLS cert path, which we can leave blank. It's just LNCLI requires us to specify it. And then the macaroon. Oh, geez. It's like, yeah, it's going off my screen.
There you go.
Holy cow. All right. Macaroon path, which I'm going to specify the macaroon path that I'm just reading from above. Okay, and then so this is like kind of the parameters for LNCLI to communicate with my node to send a payment. This is what I'm trying to do. Is I'm trying to send a payment to post to the bulletin board. And so we specify the server, the RPC endpoint, and then the macaroon path, so like that API key essentially. And then there's the command of send payment, which is an obvious name. It sends a payment. And then we have to specify that this is a key send payment. And then we need to tell it the destination, who am I paying, where is it going, and we can grab that from this log here of like, okay, this is the node that's listening, so we're going to pay this person, and then the amount, so how much do you want to do? For this example, I'm not requiring a specific amount, so we'll do 2 sats, and then you have this data flag, which is that it's essentially the means to add in that TLV value. And so we want to give it the key of 420, 420, and then we can give it whatever message we want. This API, for the sake of fun, requires that it has to be hex encoded. So we have to use some like bash magic to like hex encode it. Annoying that we're not going to get into, but so we have to hex encode the message. And it's going to try and send a payment out. It's in flight, and then it succeeded. So it just posted a new message, and so we should be able to go back to our bulletin board here. It won't let me zoom in anymore, so this is the best we got. And we see a new message pop up here. Don't open Slack. Come on, man. And so I set the message as an environment variable, and so we'll update it here of new BBB demo message. And so, what am I doing wrong here? Oh, I'm echoing it. Sorry. Okay, so now we updated that message, and so we'll send another payment and see what happens. And so it's in flight. It succeeded. And so now we can refresh here, and we see the new message pop up here. And we can look in the logs of the server that we can see I logged out some things here around the invoice was settled, and then this is the message that we found inside of the TLV. So things are working. So now we can, we're fighting spam, and that we require someone to actually send a payment with their message, and it, disincentivizes someone to spend $1 million spamming my great bulletin board. And so with that, so we can, there's you could take this to the next level, and that there's also ways where, so this is something that I was going to do, but I wrote this demo on the plane here, so I kind of ran out of time. But there's things that you can do with something inside of LND that's called the HTLC interceptor. So as payments are coming in, you're able to grab the HTLC and do something with it. You can either fail it or settle it or just hold it. And so if you want to take this to the next level, like let's say instead of just requiring a payment, we also want to like do some like natural language processing on it to make sure that it's a positive message. We want to not allow anyone to send a negative message to our platform. We only want positive messages. And so you could listen for the HTLC interceptor, like pause the HTLC, check that message against like an NLP engine and say, okay, this was a positive message. We're going to allow the payment to go through. Or if this is a negative message, you could fail the HTLC so the payment never comes to you at all. And so this is better than doing something like accepting the payment and then issuing a refund or like sending it back, because that can get complicated. Did you have a question?
Can you like penalize, like charge more every time that you do like a negative message, say? That way they can still get the disincentive to continue doing it.
So one of the problem or benefit, depending on how you look at it, is that when you don't know who is paying you inside of the Light Network. When you have an invoice, you don't know who actually paid it. You can just see it came in on this channel, and so you could. There's ways you could add some like custom logic to like have like a user ID or something that needs to be an additional TLV value and penalize on that or something. But like if you were actually trying to penalize based on like node PUBG or something, you couldn't really do that because you don't know where it's coming from. But there's things that you could do for that. But to my example, it's better to like fail the HTLC than accept it, find out that the message was bad, and then try and send it back. Technically, you should, if the payment got there and you are issuing it right back, it should have liquidity, like to follow that same path back. But it's not always a perfect world, and that things work out exactly like that. So you could have like, hey, you sent me a negative message, you lose your money. You could do that too. But what I'm trying to, I guess, explain is that there's a lot more that you could do to expand upon this and add a lot more logic, and that actually holding HTLCs, doing some amount of processing, and then posting the result based on what that criteria is. And so, yeah, go ahead. Good question. There is. And I don't remember off the top of my head. Do you know what it is? There is a limit, but I don't remember exactly what it is. And this is a good question of like, okay, so what should you be putting on the Lightning Network? Should I create a Netflix that is just streaming Lightning payments, which is like kind of, it's a cool idea in that, okay, I'm only paying for what I use inside of Netflix or something like that. But actually streaming a video over these like 1 kilobyte like little payments that's not going to work. And so when you do something like that, it's like thinking about like Impervious or something that is like creating like a VPN software. You shouldn't route your VPN through the Lightning Network. It should be an out-of-band like peer-to-peer VPN service that is tied into Lightning payments. And with Lightning, you're able to like cryptographically prove that like an invoice was paid, and actually like link like this is getting beyond this presentation, but you could actually like link like the pre-images to other things out of band of the Lightning Network. And so there's a lot that you could do to it's my opinion that you shouldn't put a lot of things inside of like the Lightning Network and like these TLV values. Rather, you should actually like do things out of band and link into payments in some way. Does that make sense?
Use it as an authenticator.
Yes, exactly. And so you shouldn't. There's a lot that you could do with TLV values. You shouldn't like pack them with data though, because you think about everyone that's routing payments like across the network. Like everyone, like if you're packing data into these TLV values, and then you have you're routing through 10 people. 10 people have to like carry that data, and then they have to like store it and all of this stuff. Like it's burdensome to the network to actually pack these with data, and so it's good to keep them light and handle things out of in a different way. How am I doing on time? I got about 10 minutes. Okay, so great. So that's essentially the demo. Any questions on the demo itself? Yes.
What's stopping someone from just flooding the network with data if you can like fill it with as much as you want?
Nothing. I mean, really, so this is kind of like attack vectors. Like people have been I think talking more and more about with things like channel jamming and stuff like that. And that's like essentially what's called like a grief attack, where you could bring down someone's node by just flooding them with gigabytes of data. And there's not. I don't think that implementations have a ton of prevention mechanisms for that today. They probably will in the future. But you could, if someone's just sending a ton of data, just disconnect from, don't connect to them as a peer, close channels with them. And that's the thing about the Lightning Network right now, is it's so kind of small that everyone is pretty in good communication with each other, where there has been problems where accidentally someone was flooding the gossip network and causing everyone's CPUs to just be maxed out constantly because it was sending too much gossip. And we're close enough, we're all in a Slack together of hey, can you stop doing that? And he's like, oh yeah, sorry, I'll stop. And that was it. But there are ways that you can prevent things like that happening. And additionally, with your HTLC interceptor, if you see something like that coming across your node, you could watch for things like that and block the peer, close channels, whatever. So there are ways to prevent that, but it's not necessarily baked in today. Does that make sense?
10 minutes left.
Thank you, sir.
Can all the routing nodes see your TLV message?
No, the TLV is encrypted in the onion packets, and only the recipient, the end result, can see the TLV. So if I'm routing a payment, I cannot see the TLV unless I'm the end payee.
As a router, can I stop messages with TLVs in it?
I don't think that you're able to see any of that inside of the payment. All when you get an HTLC across your node as a router, all you can really see is where did it come from, where is it going, and the amount. Basically, there might be a little bit extra, but you can't see any of this metadata inside of the payment. Yeah, Chris.
So can we maybe take a half step back? I'm curious to know what implementation of Lightning you're building on. Why did you choose that? Are there trade-offs for that implementation versus others that really kind of set that?
Yeah, no, that's a great question. So I guess there's really 4 implementations now. There's LND, Core Lightning, Eclair, and LDK. Sensei 2, which is built on LDK. But so with those, it really kind of depends on what you want to do, and it's almost it's hard to say what they're all getting very good. They're all getting a lot of tender love and care on the implementations themselves, so they're all very good in their own ways. I don't have a great breakdown of you should use this for that or something, because those waters are getting really muddy, I guess. I think that it's more around you should really look at the architecture. Core Lightning has much more of a plug-in type architecture where you can kind of maybe write those custom softwares and plug them into the node, where LND does a lot more for you, offers a lot more just out of the box, and then being able to kind of hook into the APIs. And so I think it just depends on what you're trying to do. It's again very use case dependent, and what you want to actually, how deep you want to go into actually doing the logic inside of the node. I think Core Lightning gives you more opportunity to do that, where LND does more things for you. And then LDK is that's just a toolkit where you build your own node entirely. And so I don't recommend that unless you know what you're doing and what you want to actually accomplish there.
And so what is this built on?
This is LND. I was using LND today. Yeah.
I played around with BlockDaemon a little bit, and this kind of reminds me of that for Lightning, just an easy way to.
Yes. Yeah. Definitely. Yeah. And that's what Voltage is essentially. We're kind of a block daemon, but specifically focused on Bitcoin and Lightning. Yeah. A question in the back.
Is there any way that you can adjust the transaction cost for any specific message, or kind of regulate the transaction cost for the message?
Regular transaction cost I don't think that you can do it per message. with all routing inside of the Lightning Network, you can set routing fees. So you can set fees on your channel of, for a payment to pass through this channel, I'm charging 1% or 2% or whatever. So you can set them on the channels. I don't think that you're able to set a per transaction fee. Someone correct me if I'm wrong in this room, but I don't think that you're able to set a per transaction fee. It's more, all the fees are on the routes themselves, the channels.
Technically, you just
initially setting up the cost of the message, and that will apply to all the messages?
Yeah, when you set fees on a channel, it's applying to every message that comes in across that channel. So they're a little bit more general. Paul?
Could you explain the difference between, this is key send versus like an invoice?
Yes, that's a good point. So this is using keysend, like I said. A flip side of this, like if you didn't want to use keysend or something, like you could, on your bulletin board UI, say, I want to post a message, and then you generate an invoice and display it, and then they can pay that invoice with the TLV data. I think that, for the sake of this demo, that's a little bit more, it's not as good UX instead of just sending a payment. But that's the flip side of this. Instead of just doing keysend, you could generate invoices, and maybe that's a way for your question of like mapping them to a user, knowing that this user generated this invoice, and then I could do that penalty mechanism and things like that. Does that answer what you're asking? Okay. Yeah.
On the voltage nodes you were running earlier, do each of those download the full blockchain when you open them? Are they all full nodes?
Yes, that's a good question. We have a tiered system on our node. So we have a light node, which is backed by Neutrino, so that doesn't use a full node. It uses Bloom filters. Google that. I won't get into all of that stuff right now. And then we have a standard node, which does use a Bitcoin full node as the backend. And then we have professional nodes that also use a Bitcoin full node as the backend. But we have kind of a system built around the Bitcoin nodes that the Lightning nodes connect to maximize efficiencies. But essentially, they can connect to a Bitcoin full node and operate with all of that. Yeah.
Do you have any idea how many transactions per second those nodes can handle?
Yeah, that's a good question. And there's been some tests and stuff. I can't remember. I mean, Joost Jaeger did from BottlePay did this whole study on TPS of Lightning nodes and stuff like that. I cannot remember those numbers, but it's decent. I want to say it was in the hundreds or something. And with that, I think that there's a lot of, I don't think TPS has been a focus for development, but I think there's a lot of improvements that could be done to increase TPS. I just don't think we're there yet as a network to be worried about TPS, but technically, you can increase TPS a lot with sacrificing a little bit of assurance of okay, maybe this doesn't get written to disk in time or something like that. It's it can get very hairy, but I think TPS today is in the hundreds.
Could you chain a bunch of nodes together? Or you have to have a bunch of different invoices? I'm not sure if that would make it complicated.
You could. So it's a good segue. Good job bringing that up, because I'm also getting close to out of time. So when you go to how do you go to production? Say you want to, okay, this is great. I want to launch this on mainnet. I want this to be real and users and everything. What do you do? And so number one, you need high availability architecture, like I mentioned earlier. And to kind of answer your question is that you could, we usually do recommend having multiple nodes. And it's good for just the high availability. One needs to get updated, one crashes, whatever. You have another one to process payments. But then additionally, you are able to kind of shard that TPS across many nodes, where if you're round robining 3 nodes and generating invoices, your TPS essentially increases by that number of nodes. And so that is a thing that you can do, and it is a potential solution today. And then another thing that I always recommend is test on mainnet. I even was a victim of this when I was creating Voltage, of you test everything on testnet and you think that, okay, it's great, and then you go to mainnet. Mainnet is a whole different beast as far as blocks go, because there's actually real transactions in there. Blocks are more full, things operate a little bit differently. So always test on mainnet. Don't assume that testnet is a great validation of mainnet. And then lock down everything. Do those things that I was mentioning earlier about making sure your API endpoints aren't exposed to the world. You have those locked down. Your macaroons are locked down. And then observability. So there's a lot that can go into the security and observability piece of it, and that's solutions that we're creating with our product Surge. And so those are just critical things you need to go into production with. You don't want to go to production with a node that is not prepared to go to production and then something bad happens. So test, do all those things to do that. So yeah, I think that that's the end of it. So I have 2 minutes if there's any additional questions. Okay.
Actually, I'll have a question.
Yeah.
Voltage specific about your infrastructure and high availability and everything like that. Since those are hot wallets, is any of that encrypted or anything like that when you create those disks or virtual machines or anything like that?
Yeah. So that's a great question. So like essentially everything is encrypted. Like disks are encrypted. When you create the node, you set a password to the node that we don't even see. So it's in like all of like your macro and C phrase, everything is encrypted to that password. And so to answer your question, yes, literally, I think everything. I mean, basically everything is encrypted, and the main encryption mechanism is that password that you set at node creation that Voltage can't even see. So that's why we have all those warnings of you lose your password, we can't help you. So yes, everything is encrypted all the time.
Well, since it is, you're become the counterparty though. In that instance, like if I'm Nomad, you're my counterparty, right? So
And it was
like flight risk or anything like that.
yeah. I'm like there's like just like some trust involved of like we have to keep your node online and things like that. Like yeah, it's not. There's no way to do hosting in a really trustless way, but there's, we can't see the data inside of your node. We can't move funds. We can't do any of that. But you have to like trust us that, hey, we're going to keep your node online.
You provide like liquidity or local balance or anything like that?
Yeah, so with our platform, we offer the nodes. We have integrations like ThunderHub, LN Bits, a lot of those tools. We do have like a we have some liquidity solutions today. We have Flow, which uses Lightning Labs' pool product and sidecar channels, as well as we have a way for just like to get a channel from like our Voltage node in the dashboard. We're definitely building out liquidity tools. So yeah, we're building out kind of the full services around Lightning.
Last question, sorry, God. Do you reverse proxy by chance?
It depends on so we have our APIs, we have like the node APIs, all of those things, and so there are like reverse proxies in there, but it's a complicated setup across like the board.
Can I reverse proxy from you for privacy for receiving? Way too complicated.
I'm not following your question. After this, follow up with me.
Just great. Are you plans to support Core Lightning and/or other implementations?
You had to ask. Yes, no, absolutely. Yes, we're planning on adding Core Lightning. It's actually being worked on right now. So expanding out our implementations, all of the tools. So yes, absolutely. Yeah. Cool. I think that I'm at time. So thank you, everyone.